Hello everyone, in this video we're going to learn how to solve the AP Calculus AB 2024 free response questions. Alright, so we're going to move on to question number 1. Question number 1A. Approximate C prime of phi using the average rate of change of C over the interval 3, 7. Show the work that leads to your answer and include units of measure. Right. So the average rate of change of f of s over the interval AB is given by the formula f prime of C equals f of B minus f of A over B minus A, where C is in the interval AB. Alright, so now we have the interval 3, 7, right? So we have C prime of phi equals, now phi right here, this is 3 right here, this is 7 right here, so phi is in the interval 3, 7, right? At C of 3 is going to be 85, C of 7 is going to be 69. Alright, so we substitute over here, so it's going to be C7 minus C3 over 7 minus 3. C of 7, 69 minus 85 over 4. So it's going to be, alright, 69 minus 85 is going to be negative 16. Negative 16 divided by 4 is going to be negative 4. So negative 4 degrees Celsius per minute. Use a left remain sum with 3 sub-intervals indicated by the data in the table to approximate the value of interval from 0 to 12 ct of dt. Alright, so we look at this one. 3 interval and left remain sums. Alright, so the left remain sum, find the delta s right here. Delta s equals 3 for this guy, 4, and this guy, 5. Alright, now the left remain sum, which is C of 0 equals 100 right here, 85 and 69. Alright, so the interval from 0 to 12 ct dt equals 3 minus 0 f of 0 plus 7 minus 3 f of 3 plus 12 minus 7 f of 7. Alright, 3 minus 0 could be 3, f of 0 it could be 100, f of 3, 85, f of 7 it could be 69. So it's going to be 100 right here times 4, 8. Plus 4 times 85 plus 5 times 69. Alright. Three times 100 is going to be 300 plus 4 times 85 plus 5 times 69. It's going to be 985 degrees Celsius. Alright, next one. Interpret the meaning of 1 over 12 integral from 0 to 12 cities dt in the context of the problem. Alright, so we're going to use the average values of a function. 1 over 12 integral from 0 to 12 ct dt is going to be equal to 1 over 12 minus 0 integral from 0 to 12 ct dt. Alright, so this is the average temperatures of the coffee in degrees Celsius over the interval 0 12. Alright, let's move on to question C. For T from 12 to 20, the rate of change of the temperatures of the coffee is modeled by C prime of T equals negative 24.55 times e to the 0.01 t over t, where C prime t is measured in degrees Celsius per minute. Find the temperature of the coffee at time t equals 20. So question C, we need to use the fundamental theorem of calculus. The fundamental theorem of calculus says, if a function f is continuous on the closed interval ab, and f is an antiderivative of f on the interval ab, then the interval from a to b of f of s ds equals f of b minus f of a. Alright, so we look at this one right here. C prime is for this, right? So C prime is the derivative of CT. T equal 20 right here, right? 12 and 20. Alright, so we have the integral from C prime t dt equals C20 minus C12. So we have C20 equals the integral from 12 to 20 C prime t dt plus C12. Now we just substitute values, right? The integral of this one is going to be this guy right here. 12, 20, negative 24.55 times e to the 0.01 t over t plus C12. C12 equals 55 right here. Alright, alpha window, pick number 4. Alright, so this is 12, this is 20, this guy negative 24.55 times e to the 0.01 t, which means s right here, over s, right? This is ds enter. It's going to be negative 14.6708. So negative 14.6708 plus 55. So plus 55, 40.3292. So it's approximate 40.3292 degree Celsius. Alright, let's move on to question D. For the model defined in part C, it can be shown that C the program t equals this one for t from 12 to 20. Determine whether the temperature of the coffee is changing at decreasing rate or an increasing rate. Alright, so we have the second derivative right here. Alright, so this guy always positive. Right, this guy right here positive, because t is from 12 to 20. You substitute over here any values between 12 and 20. This guy always positive. Right, this guy positive. So C the program's always positive. C the program positive. It tells us that the temperatures of the coffee is changing at an increasing rate. In other words, the rate of change of C prime T is increasing. Alright, so question D right here, you just copy the whole thing there. C prime of T greater than 0 for T in the interval 12 to 20. It tells us that the temperature of the coffee is changes at an increasing rate. Now let's move on to question number 2. A particle moves along the x-axis so that its velocity at time t greater than or equal to 0 is given by this function. There is one time t equal to tr in the interval from 0 to 2. When the particle is at rest, find tr. Alright, so the keyword right here, at rest, which means velocity is equal 0. Alright, it's not moving. So question A right here, at rest implies that VTR equals 0. So then you have this equation right here, natural log of t squared minus 4t plus 5 minus 0.2t equals 0. Right, so I'm going to add 0.2t both sides. So it turns out to be natural log of t squared minus 4t plus 5 equals 0.2t. So we just create a system of equation. Solution to this equation is the solution to this system. Y equals natural log of t squared minus 4t plus 5. And the second one, y equals 0.2t. Alright, so we're going to bring up the calculator. Y1, we're going to input natural log of t squared minus 4t plus 5. So give it s squared minus 4s plus 5. And the second one is going to be 0.2s. Alright, don't forget to adjust the window. Right, s means you put 0, s max you put 3, because the interval right here is 0 to 2. Alright, so you put 0 to 3. That's contain 0 to 2. Alright, the scale 1, y means 0, y max 5. The scale for y is going to be 1. Hit graph. Alright, so the first intersection is going to be right here, because the domain is from 0 to 2. So this is 2, this is 0, this is 2. So we need to take the first intersection right here, not the second one, okay? So ignore this one, just use this one. All right, so you hit second choice, number 5 right here. All right, we hit enter 3 times. 1, 2, 3. All right, s equals 1.426. All right, so t equals 1.426 seconds. For t between 0 and tr, is the particle moving to the right or to the left? Alright, so from t greater than 0 to 1.426, you see the graph right here, Vt greater than 0. Or you can pick a number between 0 to 1426. You substitute over here, you will see that Vt is greater than 0. Right, so for example, I check V1. It's going to be natural log of 1 square minus 4 plus 5 minus 0.2 times 1. It could be 0.2. So it could be natural log of 2 minus 0.2. Alright, so we have natural log of 2 minus 0.2. Right, it's going to be 0.493. It's going to be greater than 0. Greater than 0. Right, so Vt is always greater than 0 for t between 0 and 1.426. The particle moving to the right. Alright, let's move on to question B. Find the acceleration of the particle at time t equals 1.5. Alright, so acceleration is the first derivative of the velocity. So we have Vt equals natural log of t squared minus 4t plus 5 minus 0.2t. Now the velocity derivative is going to be acceleration. Alright, so we're going to take the derivative of this one. Remember, recall. Natural log of u derivative is going to be u prime over u. Alright, so this u equal t squared minus 4t plus 5. Derivative of this one is going to be 2t minus 4 over t squared minus 4t plus 5 minus 0.2. Now we need to calculate the acceleration as 1.5 seconds. So we just substitute over here. We have 2 times 1.5 minus 4 over 1.5 square minus 4 times 1.5 plus 5 minus 0.2. Alright, now 2 times 1.5 is going to be 3. 3 minus 4 is going to be negative 1 over, this is 2.25, and this is negative 6 plus 5 is going to be negative 1. So it could be 1.25 minus 0.2. Negative 1 divided by 1.25 is going to be negative 0.8 minus 0.2. So it's going to be negative 1. Alright. Now, is the speed of the particle increasing or decreasing at time t equals 1.5? Alright, so we need to find the velocity as 1.5. It's going to be natural log of 1.5 square minus 4 times 1.5 plus 5 minus 0.2 times 1.5. Alright, so we're going to use a calculator for this one. Natural log of 1.5 square is going to be 2.25 minus 1 minus 0.3. So it's going to be negative 0.0769. So approximate negative 0.0769. Alright, so we see that the acceleration is negative. The velocity is negative. So since the acceleration and velocity have the same sign at 1.5, this tells us that the particle is speeding up. In other words, the speed is increasing. Velocities, acceleration, positive, positive, same side, negative, negative, speed up. Our speed is increasing. Right? If this is positive, this is negative. If this is negative, this is positive. Right? Opposite sign. Slow down. Our speed is decreasing. Same sign. Opposite sign. Alright, let's move on to question C. The position of the particle at time t is st, and its position at time t equals 1 is s of 1 equals negative 3. Find the position of the particle at time t equals 4. Question C. Now we need to use the fundamental theorem of calculus. So we have the integral from 1 through 4 of Vt equals S4 minus S1. Right? When you integrate the velocity function, you get the position function. Alright, so it turns out to be S4 equals the integral from 1 to 4 of natural log of t squared minus 4t plus 5 minus 0.2t, right, dt plus s of 1. Alright, so we just bring up the calculator. Alpha window number 4. Alright, this is integral from 1 to 4. natural log of s square minus 4s plus 5 minus 0.2 s ds. Hit enter. Alright, it's gonna be 0.197. So approximate 1.197 plus s of 1 equals negative 3. So it's gonna be minus 3. Negative 2.803. So approximate negative 2.803. Alright, let's move on to question B. Find the total distance traveled by the particle over the interval 1 and 4. Show the setup for your calculation. So question D right here. Write the total distance. We need to integrate the velocities over the interval 1, 4. Alright, so 1, 4, absolute value of Vt dt. It's going to be interval from 1 to 4. Absolute value of natural log of t squared minus 4t plus 5 minus 0.2 t dt. Alpha window number 4, interval from 1 to 4. Alright, so we need to hit absolute value, so we hit alpha window number 1 right here. Absolute value of natural log of t squared s squared minus 4s plus 5 minus 0.2 s ds. Hit enter. Alright, 0.958. Approximate 0.958. Let's move on to question number 3. The depth of seawater at a location can be modeled by the function h that satisfies the differential equation dh over dt equals 1/2 h minus 1 times cosine t over 2, where ht is measured in feet and t is measured in hours. Afternoon t equals 0. It's known that h of 0 is equal to 4. A portion of the slope fields for the differential equation is provided. Scatter solution curve y equal ht through the point 0, 4. Alright, so point 0, 4 is going to be right here. Alright, so now we need to scatter solution curve. Alright, so it's going to be like this. Alright, let's move on to question B. For t's between 0 and 5, it can be shown that ht is greater than 1. Find the value of t's for t from 0 to 5 h, which h has a critical point. The critical points occur when h prime of t equals 0. Or h prime of t is undefined. Alright, so the h over dt is going to be right here. So we have 1/2 h minus 1 times cosine t over 2 equals 0. Now, because h is greater than 1, right? H greater than 1, which means h minus 1 greater than 0. Right? So we have this guy right here greater than 0. Right? So this guy multiplied by this guy equals 0, only cosine t over 2 greater than 0. But 0 is going to be cosine pi over 2. So we have t over 2 equals pi over 2 plus k pi. For case is the integer, right? Because we look at the unit circle right here. So this is cosine and this is sine. Alright. Cosine equals 0 when the angle is pi over 2, 3 pi over 2. Alright, so pi over 2 at k pi. K equals 0, you get pi over 2. K equals 1, you get 3 pi over 2. And then 5 pi over 2. Now we multiply both sides by 2, so t equals pi plus k 2 pi. Now t equals k equals 0, it's going to be pi. K equals 1, it's going to be 3 pi. K equals 2, it's going to be 5 pi, etc. Now, we look at the domain right here. Domain t is from 0 to pi. Alright, so t is from 0 to pi, only this one satisfies the domain, right? Because this guy is going to be 3.14 something. Alright, so only t equals 5 satisfy the domain. T is from 0 to 5. Determine whether the critical point corresponds to a relative minimum, relative maximum, or neither a relative minimum nor a relative maximum of the depth of seawater at the location. Alright, so recall. So this is the value of t over the interval a, b. Now, suppose we have t1. This is f prime of t, and this is f of t. Alright, this is a critical point makes f prime of t equals 0. So, suppose this is negative, this is positive. F prime of t is changing from negative to positive. This is going down, this is going up. We get the relative minimum. Now, similarly, we have the second one. This is t, this is f prime of t, and this is f of t. A, B, we have t1 right here, 0. Now f prime of t changes from positive to negative. This guy going up, this guy going down. So we get the relative maximum. Alright, so we have the table. This is t, this is h prime of t, and this is h of t. This is 0, phi, and this is pi. So since pi is the critical point, so this guy must be equal to 0. Alright, now we're gonna put a value t equals 2 in this interval. So we substitute into h prime of t. So we have h prime of t is gonna be right here. It's gonna be 1/2 of h minus 1 times cosine 2 over 2. Alright, so because at is always greater than 1, so this guy always positive. So cosine 2 over 2 it could be cosine 1 greater than 0. So h prime of t is always greater than 0 on the interval 0 to pi. So this guy should be positive. This guy should be negative. So this guy's going up. This guy's going down. And this is relative maximum. Alright, let's move on to question C. Use separation of variables to find y equals h of t. The particular solution to the differential equation dh over dt is equals 1/2 h minus 1 cosine t over 2 with initial condition dh over dt equals 1/2 h minus 1 cosine t over 2. Alright, so we have dh over h minus 1 equals 1/2 cosine t over 2. dt. Alright, now we're going to integrate both sides. 1 over h minus 1 dh equals 1/2 cosine t over 2 dt. Now integrate this one is going to be natural log of absolute value of h minus 1 equals, now recall the antiderivative of cosine of as plus b ds is going to be 1 over a sine as plus b plus c right here. Alright, so this guy turns out to be 1 over 1/2. Alright, so we have 1/2 right here times 1 over 1/2 sine t over 2 plus c. Alright, now 1/2 cancel out. Now because h, remember we have the condition right here, h of t is greater than 1, right, for every single t between 0 and 5. Alright, so h of t is greater than 1, which means h minus 1 greater than 0. So we need to remove the absolute value of this one. So it turns out to be natural log of h minus 1 equals sine t over 2 plus c. Alright, now we have the initial condition. It's going to be h of 0 equals 4. Alright, so we have natural log of 4 minus 1 equals sine 0 divided by 2 plus c. Alright, so c equals natural log of 3. Now substitute back over here, so we have natural log of h minus 1 equals sine t over 2 plus natural log of 3. Alright, so h minus 1 equals e to the sine t over 2 plus natural log of 3. Alright, but this guy right here, we just separate them, so e to the sine t over 2 times e to the natural log of 3, right? But e to natural log of 3 is going to be 3, so it's going to be 3 times e to the sine t over 2. Alright, so finally h equals 3 times e to the sine t over 2 plus 1. Let's move on to question number 4. Alright, question A. The function g is defined by g of s equals the integral from 0 to s f of t dt. We need to find the value of g of negative 6, g of 4, and g of 6. So we have over here g of negative 6 is going to be integral from 0 to negative 6 f of t dt. Alright, now we just change the bounds right here and we change the size, so it could be integral from negative 6 to 0 f of t dt. Alright, so we look at this one. Negative 6 right here, 0 right here. So the integral from negative 6 to 0 f of t dt is the error of this region right here. Alright, but we have it 12 right here, so it could be negative 12. Next one, g4 equals the integral from 0 to 4 f of t dt. Alright, from 0 to 4 it's going to be right here. This is actually the error of this triangle right here. Alright, so equals 1/2 base times height. Right, base equals 4 right here, and height is equal to 2. So it's going to be 1/2 4 times 2. So the answer should be 4. Now, g of 6 is going to be integral from 0 to 6 f of t dt. Alright, 0 to 6 we have 2 regions right here. The triangle on the top and the triangle on the bottom right here. So it's going to be integral from 0 to 4 f of t dt plus the integral from 4 to 6 f of t dt. Alright, so integral from 0 to 4 is going to be 4. Integral from 4 to 6. Alright, because this guy is below the x-axis, so it should be subtraction. Now we need to find the error of this one, so it's going to be the base equal 2. And the height should be 1. So it could be 1/2 1 times 2. So it could be 3. Now let's move on to question B. For the function g is defined in part A, find all values of s in the interval from 0 to 6 at which the graph of g has critical point. Okay, so we know that the critical points occur when g prime of s equals 0 or g prime of s is undefined. Now we have g of s is the integral from 0 to s of f of t dt. So we're going to take the derivative of this one, so g prime of s it's gonna be f of s, right? We just substitute s over here. When we take the derivative, we just substitute s over here. So we have f of s right here. Alright, so g prime of s equals 0, then f of s must be equals 0. Alright, so we have the domain 0 to 6. So it's going to be from here to here. F of s equals 0 when s equals 4 right here. Right? So s equals 4. The function h is defined by h of s equals integral from -6 to s f prime of t dt. Right? So we have h of s equals -6 to s f prime t dt. Find the value of s of 6, h prime of 6, h double prime of 6. H of 6 equals the integral from -6 to 6 f prime of t dt. So by fundamental theorem of calculus, we have f of 6 minus f of -6. Right, f of 6 right here equals -1. F of -6 equals 0.5 minus 0.5. So it's going to be -1.5. Next one, h prime of 6. So from this one, we have h of s equals f of s. Then h prime of s equals f prime of s. Now h prime of 6 equals f prime of 6. F prime of 6 is the slope of the tangent line of f of s at s equals 6. Alright, so we have h prime of 6 equals f prime of 6 equals, right, rise over run. Evaluated at s equals 6. So we look at this one. From 0 to 6 right here, this is the linear function. So we need to calculate the slope of this one. So rise equals 1, run equals -2. Right, so it could be -1/2. H double primes. So h double prime of 6 equals f double prime of 6. Now we look at this one right here. From 0 to 6 right here, this is a linear function. So suppose this one has the function f of s equals a s plus b. Now take the first derivative, f of s equals a. Now the second derivative of this one, and derivative of the constant should be 0. Alright, so go back over here. This is a linear function. So the second derivative s equals 0. Because this is a straight line. In the interval 0 to 7. Let's move on to question number 5. Alright, so consider the curve defined by the equations x squared plus 3y plus 2y squared equals 48. And the derivative of this guys, it's going to be negative 2s over 3 plus 4y. Alright, there is a point on the curve near 2, 4 with s coordinate is 3. Use the line tangent to the curve at 2, 4 to approximate the y coordinate of this point. So, question A. Alright, so we need to find the function of the tangent line. So we have dy over ds equals negative 2s over 3 plus 4y. Alright, and then the slope is going to be dy over ds evaluated as 2, 4. Alright, so we substitute 2, 4 into this expression right here. So we have negative 2 times 2 over 3 plus 4 times 4. Alright, so it could be negative 4 over 19. So slope equal negative 4 over 19. Now we're going to use point slope form. So we have y minus y1 equals m times s minus s1. Alright, so y equals negative 4 over 19 s minus 2 plus 4. Alright, now y of 3 equals negative 4 over 19 times 3 minus 2 plus 4. It's going to be negative 4 over 19 plus 4. It's going to be 72 over 19. Alright, let's move on to question B. Is the horizontal lines y equals 1 tangent to the curve? Alright, so B. If y equals 1 is the tangent line to the curve, then the slope should be 0. Alright, so we have dy over ds must be 0. It implies that negative 2s over 3 plus 4y is 0. Is equivalent to negative 2s is 0 or s is 0. So we have the point 0 and 1, right? 0 right here and 1 right here is the solution to the equation. This equation right here. S squared plus 3y plus 2y squared equals 48. Now we substitute s equals 0, y equals 1 into this equation to see if both sides equals, right? So we have 0 squared plus 3 times 1 plus 2 times 1 squared. Alright, it's gonna be 5, not equals to 48. So y equals 1 is not the tangent line to the curve. Alright, let's move on to question C. The curve intersects the positive x-axis at the point root 48, 0. Is the line tangent to the curve at this point vertical? Alright, so question C right here. If the tangent line to the curve is vertical, then the slope should be undefined. All right. All right, so we have dy over ds is negative 2s over 3 plus 4y. We need to calculate dy over ds at root 48, 0. Alright, so we substitute negative 2 times root 48 over 3 plus 4 times 0. So root 48 is equal 16 times 3. 16 print outside is going to be 4. So it could be negative 8 root 3 over 3. But this one is not undefined. So there is no vertical tangent line to the curve at root 48, 0. Now let's move on to question D. Alright, for time t is greater than or equal to 0, a particle is moving along another curve defined by the equation y cubed plus 2sy equals 24. At the instant the particle is at the point 4, 2. The y-coordinate of the particle position is decreasing at a rate of 2 units per second. At that instant, what is the rate of change of the x-coordinate of the particle's position with respect to time? Alright, so we have y cubed plus 2sy equals 24. Now given the point 4, 2 and dy over dt equals negative 2, right? So right here, decreasing, which means negative side. We need to find ds over dt. Alright, so we take the derivative of this function right here with respect to t. So we have dy, so we have 3y squared dy over dt plus, now this one we have x and y, so we have dy over dt and ds over dt. So we have 2s dy over dt plus 2y ds over dt equals derivative of 24 equals 0. Alright, so now we just substitute the value. So we have s equal 4, y equal 2. So we have 3 times 2 square times negative 2 plus 2 times 4 times negative 2 plus 2 times 2 times ds over dt equals 0. Alright, now we're going to simplify this one. 2 squared equals 4, 4 times 3, it could be 12, 12 times negative 2, negative 24, and this is 2 times 4, 8, negative 16, negative 24, negative 16, and then negative 40, add negative 40 both sides, so it should be 4 ds over dt equals 40. So ds over dt is 10 unit per second. Let's move on to question number 6. Right, question A. Let R be the regions bounded by the graph of f of g from s equals 0 to s equals 2. So 0 right here, 2 right here. So this region R right here. Alright. Right, but do not evaluate the integral expression that gives the area of regions R. So question A is going to be the integral from 0 to 2. Absolute value of f of s minus g of s ds. Alright. Now, this is f of s above g of s. So, this guy must be greater than this guy. So, when you remove the absolute value sign, it's going to be the integral from 0 to 2 f of s minus g of s ds. Alright, f of s equals s squared plus 2. So, you substitute integral from 0 to 2 s squared plus 2 minus g of s is going to be s squared minus 2s ds. And then you simplify integral from 0 to 2. 2 minus plus 2s ds. Let S be the region bounded by the graph of G and the s-axis from s equal 2 to s equal 5. So 2, 5, the region S right here. The region S is the base of a solid. For this solid, at each S, the cross-section perpendicular to the s-axis is a rectangle with height equal to half its base in region S. Alright, so suppose we have the cross-section. Find the volume of the solid, show the work that leads to your answer. Alright, so we have dV equals area times thickness. Alright, so we have V equals the integral from 2 to 5. Now, we draw this one on the side. Alright, so this one, GS. This one must be GS over 2. Alright, so it's going to be GS times GS over 2 times thickness, which means ds. Right, this guy right here, ds. Alright, so it's going to be 1/2 the integral from 2 to 5 gs squared, but gs equal this one, so it could be s squared minus 2s is going to be s to the 4 minus 4s cubed plus 4s squared ds. Alright, now we're going to integrate this one, so it turns out to be 1/2 s to the 5th over 5 minus s to the 4th plus 4 over 3 s cubed. Evaluated from 2 to 5. Alright, so it turns out to be 1/2 5 to the 5th divided by 5 minus 5 to the 4 plus 4 over 3 times 5q minus 2 to the 5th over 5 minus 2 to the 4 plus 4 over 3 2 cube. Alright, so it's going to be 1/2 times this guy 5 to the 5th divided by 5 could be 5 to the 4th. So 5 to the 4 minus 5 to the 4 is going to be 0. Alright, so we have this one only 4 over 3. 5 to the cube is going to be 125 times 4. It's going to be 500. So 500 over 3. Now this guy right here, 4 over 3 times 2 cube. 2 cube equals 8. 8 times 4, it could be 32 over 3. So the subtraction side right here is going to be minus 32 over 3. 2 to the power of 5 is going to be 32. 32 over 5 minus 2 to the 4. It's going to be plus 48 over 5 equals 1/2. This guy and this guy right here is going to be 468 over 3 plus 48 over 5. And then we're going to simplify this one. It turns out to be 414 over 5. Alright, let's move on to question C. Write but do not evaluate an integral expression that gives the volume of the solid generated by the region S, as described in part B, is rotated about the horizontal line y equals 20. Alright, y equals 20, so it's going to be like this. This is y equals 20. Now we need to rotate this guy, region S, about the line y equals 20. Now we need to rotate the region S about the line y equals 20. So we're gonna get the washer. So it's gonna be like this. The distance from here to here, this is the big R, right? This is the radius of the bigger circle. And then the distance from here to here, right here. This is the radius of the smaller circle. Alright. This one right here is the thickness. So this is ds. Question C. We have dv equals area times thickness. Alright, so v is going to be pi. Right, the area of the bigger circle is going to be pi r squared. Right, so r right, the bigger one r right here, so subtract the smaller one right here. So it could be pi, the integral from 2 to 5 r s square minus the radius of the smaller one, so it could be rs right here square times the thickness is going to be ds. Alright, so v equals pi, the integral from 2 to pi. Now the bigger r is going to be the distance from here to here, which is 20, right? Right here, 20. So we have 20 squared is going to be 400 minus, now the smaller r is going to be this guy right here. So equals 20 subtract this guy right here. But this guy right here is going to be the function g of s right here. So it could be 20 minus g of s square ds. Alright, so we just substitute value. V equals pi, the integral from 2 to 5, 400 subtract 20 minus gs, but gs equals s squared minus 2s, so it's going to be minus s squared plus 2s all together square ds. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.